Good evening, star nerds. This is sorry, I wasn't going to laugh during that. This is Molly here on the Astro Imaging channel, and we're back again this week with Craig Stocks talking about networks and systems for either your backyard or your remote observatory. And so he'll be talking about that tonight. Let's see, let me go ahead and share my screen to share also what's coming up so that, you know, for hype and whatnot. Share here. So now if you haven't been around in a minute, we are now on a first and third Sundays of the month schedule. So that does mean on months with 5 Sundays, you miss 2 Sundays in a row. But this month we're on the 5th and the 19th, and then the 2nd of November, and so on. If you're not sure if we're going to be broadcasting that night, you can always go to our website, theastroimagingchannel.org, and see the calendar that I'm sharing with you here. If you subscribe to this channel, then you'll get notifications in YouTube when we're going live to remind you. And then I also post on our Facebook page at about 2 p.m. Mountain Time what the show is going to be for tonight. We have John Talbot coming up week after next with a scientific topic about nebulae around cataclysmic variables. So that should be fun. John's just joined us. Speak of the devil. After that, we have a couple of folks that are recommended to me by a guy at Astrophysics talking about Murphy's Law and how to prevent accidents from happening on your gear. And then we have Gary M back with us on the 16th, and he's recently completed a project where he's imaged the entire Sharpless catalog because he's the most prolific imager I have ever seen. So he's going to come on and talk about that, and talk about the Sharpless catalog, what it is, how cool it is, things like that. We will be off. We weren't going to be on anyways, I think, for Thanksgiving. So I think that's looks like a 5th Sunday maybe, but we'll be off for Thanksgiving. And then back in early December with Mike Cranfield talking about a pixel math UI that's makes pixel math a little less pixel mathy over in PixInsight. All right, I'll stop sharing my screen here. Let's see. So I got a topic idea from a question that was sent in to us on our website, the astroimagingchannel.org contact us page, asking about 3D printing and whether some parts could be 3D printed. So if anybody out there does 3D printing for astronomy parts and wants to come on and talk about 3D printing in astronomy, either stuff that you've done, stuff that you've seen other people do, cool things you can do with 3D printing to help your astronomy, or like I 3D printed a telescope recently. That was very cool. We'd love to have you on to talk about that topic. So you can drop us a line on the contact us page on the website. The website link is also in the video description there. All right, so let me do a brief introduction of Craig here before he gets rolling. So Craig Stocks was a professional photographer before he turned to mechanical engineering, but he continued to maintain that interest in photography. And after his retirement, I'm looking forward to that someday so I could do more astrophotography. He was the artist in residence at the Organ Pipe Cactus National Monument in Arizona, and later on a couple other parks as well. And he's now located in Southwest Utah, and established the Utah Desert Remote Observatories to host remote telescope equipment. And so he's here to talk to us about networking and systems for astrophotography. So Craig, take it away.
Okay, thank you. Let me share my screen. So you should be seeing my screen now.
Yes, looks good.
Okay. So I'm going to be talking about networks, and I guess you'd say all the fun things you can do if you have a network, whether it's large or small. But I'll touch on things like roof controls, weather systems, seeing monitors, sky quality meters, and spend a little bit more time on situational awareness cameras, which is something that I think almost anybody can use. So in terms of our observatory, Utah Desert Remote Observatories, we're open for imaging about 78% of the nights, but some of those are partial nights. So the roof may close and open during the night. So you want to be able to respond to that. In total, that provides about 2,000 imaging hours a year. And again, you get the most out of that in any remote observatory by having automation that can respond to what's happening with the roof system and the weather. Uh, to do that, your scope somehow needs to be connected to a network or to, some intelligent device so it knows what's going on and it can react appropriately. And once you get that dialed in, then you really can get the most out of those available hours. Now, you may not need a network if you have a small observatory or even just a telescope on a tripod in your backyard. You probably don't need a network, but there are some advantages if you have one available. In a simple application, you of course can put all of your apps on a single computer. So you could have weather, roof imaging all being done by one computer. Probably then less need for a network. But you may still benefit from a small network in a larger observatory where you have multiple computers that need to exchange information. Having some sort of a local area network is really needed to solve the problem of exchanging information between computers. So in our case, we have a full duplex gigabit fiber optic to the observatory. We run about 5% of capacity. And then a 10 gigabit fiber backbone connecting the various switches on the network. Auto ping monitors, which I'm not going to talk about specifically, but an auto ping monitor is a program that runs on one of the computers on the network. And if something on the network drops off, it will notice that through an auto ping routine and send you a text and or an email letting you know that something has happened. Most important, though, is a shared network drive so that all the telescopes can have access to weather and roof status information. In a simple network, and we'll start with kind of a home network situation, your internet service provider probably provided a router that gives out a Wi-Fi signal. So you get your Wi-Fi in your house from the router provided by your internet service provider. And then with that Wi-Fi signal, you can connect your computer or other devices to that Wi-Fi signal, and now your computer's online. And of course, if you have more than one computer, you can have more than one computer, more than one device connected to that Wi-Fi. So life is pretty good. Wi-Fi is pretty good. It's not as fast and as reliable as if you use a wired Ethernet connection. Fortunately, most routers, if you look on the back, are going to have a series of Ethernet ports. In this example, it has 4. And I can just plug an Ethernet cable into the back of my home router and then connect that to my computer. And now that computer's connected via a wired Ethernet connection rather than depending on Wi-Fi. So it will probably be faster and would almost certainly be more stable. And that doesn't interfere with the Wi-Fi signal. I can still have other devices using Wi-Fi. So just that simple switch from using Wi-Fi to using an Ethernet cable gives you some benefits. In an observatory situation, you generally have more devices than just the computer. For instance, you might want to use a remote power switch that will connect also somehow over your network. And then you can remotely turn the power off and on to various devices by toggling the power through these remote controlled switches or outlets. Real handy in an observatory if you want to power cycle something without having to walk out there and do it. But in this example, we've got one Ethernet cable that's going out to our computer in our observatory. Rather than running 2 cables out to the observatory, we can use what's called an unmanaged Ethernet switch. And these are pretty inexpensive. This one I think is around $15. And it's basically a splitter for an Ethernet cable. So instead of running the Ethernet cable to the computer, you run the Ethernet cable to this unmanaged switch. And then from that switch, you can run a short Ethernet cable to your remote power switch and another one to your computer. And now you have 2 devices on that Ethernet port on your router. And you've got kind of the beginnings of a true local area network. If you want to add other devices to that Ethernet switch, You might add a camera to watch your telescope and see where it's pointed. You might have a weather system that runs off of an Ethernet connection. So you can start, really leveraging this little switch and connecting other devices as well as your computer. And then that all goes via an Ethernet cable back to your router. So that's kind of the start of a very simple, basic network that you could use in a large observatory, a small observatory. A lot of this equipment you might even want in your backyard. You might as well go a step further then and add what's called a network attached storage, or NAS. And this is basically a set of disk drives that connect via Ethernet, and it gives you the ability to have a shared network drive that all of the computers on this network can now access this shared drive and share information. One computer could write information to the NAS, and then another computer could read that information from that same shared folder or shared drive. So now you truly have a functioning local area network. Ethernet switches kind of come in two basic types. A plain one, which is the one I showed in the example. This one was going for around $16 when I put this together. Another version of these supports what's called power over Ethernet. Some devices are able to get their power entirely over the Ethernet wire, so they don't need a separate 12-volt plug. And that's real handy for things like web cameras and also the weather systems. For those, you need to inject this power over Ethernet into the Ethernet cable at some point. Fortunately, they also make unmanaged switches that provide PoE outlets. So in this case, it's $49 instead of $15 or $16. But the advantage is it not only works as a switch, it also provides power for those devices that can be operated via the power over Ethernet. So we've talked about some of the benefits already. Across the internet, you can get remote access to your imaging computer using a remote desktop application. You can get remote access to other network devices. By accessing your computer, then you can access other devices. And you can automate file transfer so that as your imaging computer is doing its work, it could be automatically transferring files to your home computer or your processing computer, and save the old sneaker net of moving disks or thumb drives back and forth. And then, of course, on that local area network, you can share drives. You can also create a backup protocol so that you can start using that network attached storage as a form of backup for all the computers that are on that network. And it even lets you share tasks across computers. So you might have a separate computer that you're going to run some of the more computational intensive tasks from PixInsight on a separate computer, and not bog down the one that you're playing solitaire on. So I do that. I use Google Remote Desktop. Other people there's AnyDesk or TeamViewer. There's a variety of different remote access tools that you can use. I've had real good luck with Google Remote Desktop, but I can use that to access my imaging computer from not only my home computer, but from my phone or my tablet. It's very versatile, and it just presents you with a list of all of the computers that you have associated with that Gmail account. So in this case, I have a PixInsight processing computer. This is an imaging computer at the remote observatory. This is a solar scope in my backyard, and this is another remote scope at the observatory. So I could connect to any one of these just by selecting it, and then my keyboard, mouse, and monitor on my home computer shows the keyboard, functions as the keyboard, mouse, and monitor of the remote computer. And these remote computers don't even have a monitor or keyboard attached. I mentioned automated file transfer. I use Dropbox with synchronized folders. So I have a capture folder on my imaging computer that all of my subs go into that capture folder. And then as they're created, they're automatically synced to the folder on my home computer. So when the capture computer writes a new file, about 10 seconds later, it shows up on my home computer's hard drive. So they're transferred automatically as they're captured. And then I use a simple tool in Windows called a batch file, which gives you the ability to capture command line commands into a text file, and then you can execute that text file as if you were typing commands at the keyboard. And a simple one is just to copy the files that are in this uh, synchronized folder on my home computer from that synchronized Dropbox folder into a permanent folder. And then once they're copied, I can delete the files from the synced folder. And the contents of that file just says, in this example, the folder is Nook 1 Dropbox. So it just captures the current time. This X copy is the thing that does all the work. It's going to copy from my users, Craig, Dropbox, Nook 1 Dropbox data, all files, and it's going to copy any new files or changed files to my D drive into the Nook 1 folder, and it'll create new subfolders, and that's what all of these little switches do. But it takes it about 5 seconds, and it moves all the files from Dropbox folder into a permanent folder. Then I can delete everything in the permanent folder, and I'm ready for the next night. I mentioned shared drives. I've used Synology NAS products, and this is a NAS and an extension. The drives can be configured in RAID arrangements, which, without getting too deep into the weeds, what RAID really does for you is create some fault tolerance. So mine are configured as RAID 6, which means that any two drives can fail and I won't lose any data. So you shouldn't look at that as something that doesn't need backed up. You still need more than one backup, but having that fault tolerance and the little indicator lights makes it much more robust. It attaches via an Ethernet cable and an unmanaged switch to my home network. And so when I look at my drives on my computer, I've got a C drive, a D drive, and then on my NAS, I have a T drive, which has all my Astro data, and a Z drive that has all of my other backup data. And then we also use same configuration, but a much smaller NAS at the observatory to provide a shared drive there. But that allows a shared drive now that can be compared and shared across computers on the network. So I mentioned a backup protocol, and a NAS is really a great option as part of your backup protocol. Uh, Depending on your Ethernet speed, but assuming you have gigabit local Ethernet, then it's going to be faster than USB 1 and USB 2, probably a little slower than USB-C. But don't rely entirely on the NAS as a backup. You want it to be part of an overall backup strategy. So my technique for backup, I again use a batch file that will copy everything on my hard drive on my main computer to the NAS using the technique of it adds any new or replaces any changed files. So a file, once I've copied a file over to the NAS, if it never changes on my main computer, then it never gets backed up again. And it also never gets deleted. I can delete from my main computer and nothing gets deleted from my backup, but it will add any new files or folders. And if any files are changed, then it will replace older files. And then once it's backed up to at least 2 locations, I can safely delete files from my hard drive. And these 2 lines are basically what I use to do my backup. So it's, again, in a batch file using the xcopy command, copy everything from my Astro folder to the T drive and everything in my C users folder to the Z drive. And that does a pretty complete backup of all the important files on my computer. It also lets me share tasks across computers. That I recently added a second computer kind of dedicated to just processing PixInsight. I can work on multiple image sets at once by having two computers. So it's really great for long batch processes like WBPP. And that combination of remote desktop and a shared drive environment lets me do that very easily. So if I start my workflow from the capture computer, so this would be the remote computer that's capturing the data, it saves the file into Dropbox, which synchronizes it to my home computer. In my home computer, then I'll move the data from Dropbox. We just talked about the batch file that does that. I'll blank everything in PixInsight to remove any bad subs. And then I just do a backup of all of my new good data, and that copies it over to the NAS. So now my T drive on the NAS has all of my new data. I can then, still sitting at my main computer, access this Astro Pi computer, and I can load files from the NAS, run WBPP, save the masters back to the NAS, and then I can come back to my main computer, which is where I do my Photoshop processing, and load those masters from the NAS as TIFFs, process those in Photoshop, and then save them on my C drive as a finished master file. So that process, and that also lets me, if I want to, I can run WBPP simultaneously on different data sets on both the remote computer and my main computer.
Craig, I
Yeah,
have a quick question.
sure.
So how do you handle versions of a final image? You just rename them, or do you keep multiple versions?
I just rename them. So I would, it's not unusual for me to image the same target over multiple nights, but I usually will process it at least partially after each night. So I might save night 1 and night 2 and night 3 with different names. And it chews up hard disk space really quickly. So I frequently, after I have everything backed up at least twice, will start purging some of those big files off of my hard drive.
Greg?
You know what happens next, right, after you purge it?
Typically your computer crashes.
Oh, no, I see. Then you need it.
Yeah. But it's still available. It's
Alex.
just on the shared drive, so I can pull it back in very easily.
Alex, go ahead.
Greg, we've had some other questions come in.
Okay.
The main one is, okay, so I'm sitting here in my house and my observatory's in the backyard. How do I connect my house back to there, back to the computer back there? And I think you're probably going to be talking at some point about, okay, my other observatory is out in the desert 2 hours away from here. How do I connect to it out there from my home computer? If you're going to cover that, well, we'll just wait till you cover it. But
not specifically, but we can talk about it a little bit.
Okay.
In terms of the backyard, the ideal is to run an Ethernet cable out to your backyard, and I know that's much easier said than done. Another alternative is to use a Wi-Fi extender, and you'll notice most Wi-Fi extenders have an Ethernet port on them. So, and in fact, I did that in my backyard for quite a while. I had an Ethernet extender plugged in. I had to plug it in on one of the outdoor outlets on a back porch where it was somewhat protected. And then I could either run an Ethernet cable from that, because now I had an Ethernet jack on the outside. And the Wi-Fi extender not only extends the Wi-Fi, it also gives you an Ethernet jack that you can plug into. You could also put a Wi-Fi extender on your telescope or in your observatory in your backyard, and then run an Ethernet cable from that jack on the Wi-Fi extender to an unmanaged switch, and then from there split out to the various devices.
Okay, that question came from John at Astra, and I think that probably answers some part of it. Although, as he says, he wish he would have known about that Ethernet cable before he built the observatory. It's hard getting under that cement, isn't it, John? And where is that question? I just saw it and it's going by it. What are the problems mixing Mac and PC? Microsoft products? That's from Marcia.
None that I have seen. I don't know if she's talking specifically about Dropbox or remote desktop, but I have not found any real issues commingling those on the network. Um, the only real difference I know of on a Mac, the Dropbox folder has to be on the C drive. On Windows, you can put your Dropbox folder on a D drive, or even they recommend against it, but you could even put it on a remote or on a like a USB drive.
Thank you. And that's all the questions we've compiled so far, although I haven't been reading them as I've talked to you. So
Okay, well, just let me know if some more come in that we need to
we'll
stop
do
and
that.
talk about. So part of, because we're operating a commercial observatory, we have a web page that needs to get a lot of this information uploaded to the web page. And that does have some impact on the tools that we use, but mostly probably mostly the cameras, in terms of our choice of cameras. The weather system, all sky camera, and all these things get uploaded in some form onto our website on our weather page. So roof control, I'll talk about that first. Of course, in an observatory, you have a number of options. You could just manually open and close the roof. You can use a motorized open and close where you go out and push a button to open and close the roof. Or you can have an automated system that will automatically open and close the roof based on some parameters, usually related to the weather. In our case, we're using Interactive Astronomy's roof system, and it will automatically open and close the roof based on all these various weather factors as well as light. And it's integrated with Interactive Astronomy's weather system, so it's very easy to connect. One kind of a downside is it uses a USB connection, so you are somewhat limited in proximity of the control computer to the roof system. You can't be a long ways away. It has to be within USB distance. The weather system, again, there's lots of options. You can just get internet weather data from one of the internet websites. You can have a separate weather system that's not connected to anything, or you can use an integrated weather system. Again, in our situation, we're using the Interactive Astronomy weather system as our kind of our official weather system. And that creates a boltwood format weather file that the roof system can then read. And it's doing that over that network shared drive. So either they have to be on the same computer, or they have to have access to the same shared network drive so that the weather system can communicate with the roof system. And since we have multiple roof systems, each one has its own computer, we automatically have a need for a network environment. The weather system can use either USB or an Ethernet connection. And so in our case, we're using the Ethernet connection, and that lets us put the weather system wherever it fits well, rather than within 16 feet of a computer. We also have a separate standalone weather system that is a Tempest weather system that overall we have found it gives us better real-time data, more accurate weather data. We can access it with a phone app or internet. So it's pretty versatile that way, but it's not integrated with any of the roof controls. We've considered, we be fairly straightforward to write a little custom program to put this into the proper format and feed it to the roof system. We haven't done that because that's just one more layer of complexity that doesn't necessarily gain us much in functionality. That we know how to set the parameters based on the Interactive Astronomy weather system so that everything works the way it's supposed to. But it does take a little bit of learning and fudging. The roof system, the roof system and the weather system talk to each other, and we have both primary and backup weather systems. The four roof systems then monitor the weather conditions. The roofs open and close automatically based on clouds, wind, and so forth. And then the telescopes in the various observatories will monitor their own roof status file. So, if you're in the SAGE observatory, then you would monitor the SAGE roof status file. And probably the best practice is just use that roof status file as a safety monitor indicator, so that when the roof is open, you can start imaging. And if the roof closes, then you pause imaging or suspend until the roof either opens again or the end of the night. And that combination of tools really gets you close to being able to utilize all 2,000 of those available hours. We also have a seeing monitor that measures the seeing by monitoring the jiggle in the North Star, and then it samples hundreds of times on the North Star, calculates the deviation, and then uses some mathematical transformations to give us a measure of the seeing. And one thing I always caution whenever you're looking at seeing in particular, it's a good indicator from night to night at a given observatory. I don't think it's necessarily a good comparison from one observatory to another, because there are also a lot of local factors that can affect it. Most notably among those is the height of the seeing monitor above the ground, because you do get some thermal convection just from the ground that can affect the way the seeing monitor measures. Sky quality meter is another indicator that we just maintain online so that it's available for everybody. In this case, it's a PoE device from Unihedron outside in a weatherproof enclosure. And so by having that connected with the PoE, it's pretty flexible on where we put it. The seeing monitor is USB 3, so it's limited and has to be close to the computer. Sky quality meter is power over Ethernet. We could put that pretty much anywhere within, I think, 300 yards of the computer, and it would still operate. We also can run the software for the sky quality meter from any computer on the network. It doesn't have to be on the one attached via a USB cable. All sky cameras are a lot of fun. They can be very useful. Our main all sky camera at this point is still the interactive astronomy all sky camera. It does require a USB connection. So again, you're limited to that 16 feet or so from the computer to the camera. And this example happened to be one night last year when we had northern lights. So that was kind of fun to pick up things like that on your all sky camera. This camera does not give you the full 360 in all directions. It gives us horizon to horizon, going east and west, but not north and south. So there are other options that you could consider. The interactive astronomy camera sells for $15.99. By comparison, we have another all sky camera out there, which is this Vicilin fisheye power over Ethernet indoor outdoor 360 camera. It sells for $219 on Amazon. And again, it connects through a PoE connection, so you can put this just almost anywhere. Has a 1/4-20 thread attachment on the bottom, so it's real easy to mount. And I've had real good luck with it. Although we did have the first one die after about 3 months and 1 or 2 good rainstorms. So the company did replace it. I just sent them an email, said, hey, quit working. They sent us a new one. We'll see how this one works out. It's been through some rain so far and is working fine. So it may have just been an anomaly that the first one failed. But the price is right, but we haven't had 100% good experience with it. So as I mentioned, the interactive astronomy connects via USB. Another big advantage is it comes with all the software that you need. So you can get it up and running real easily. It does not have any kind of a mobile app, so the only way to look at it is to look at it on your computer. It does have FTP functionality built in, so if you have a website or someplace that you can put a picture online, you can use that FTP functionality and send snapshots every 30 seconds or whatever to a website to have an image online. The Vicolin connects via PoE, does not have its own software. Well, I guess it does. It uses the Hikvision mobile app to view it on a mobile device. We're using Blue Iris as the PC software to connect to our all of our PoE web cameras. It works really well, pretty easy to set up, easy to add new cameras. So we've had good luck with it. It's not, there's a little bit of a learning curve to it. It's not something that you're just going to sit down and it'll find your camera and work. You'll have to do some configuration. But once you do that, we've had real good luck with it. Other Amcrest cameras that you might consider, there's a $200, they call it a panoramic. It's a 180-degree view, but it's a kind of a long rectangle, so more like a panorama image. So it would see horizon to right, horizon in one direction, and just kind of a strip in the other direction, more constrained than the example I showed from the interactive astronomy camera. But again, for $200, that's a pretty reasonable price. If you really want to go high end, and I have not tried this because of the price tag, but this Amcrest is a full 360-degree, 12 megapixel, so it's significantly higher resolution than the Vicolin that we're using. And again, it's PoE and fully waterproof. I don't remember the IP rating, but it's IP67 or something. It's a very high waterproof rating. One of the things we've done with our all-sky camera is put together a little artificial intelligence program that can look at the all-sky camera and give us a report of whether it thinks it's clear, partly cloudy, or cloudy. And the output from that is this chart, which again is on our website, gives you the current time. And this was just, half an hour ago, something like that. And the way you read this is obviously it's currently clear and the confidence score is 100%. 1 is clear, 3 is cloudy, and anything in between is somewhat cloudy. In between 1.7 and 2.4 in a exponentially smoothed average is when this report would go from clear to partly cloudy to cloudy. And then the scale on the bottom is just roughly the last 12 hours of readings. So we can see we had a little bit of clouds come in earlier today, then it was clear all day until probably mid-afternoon, had some clouds, which have now cleared out and we're running clear. So if the line's on the bottom, it's clear. Creating that AI model was really easier than you might think, thanks to the Google Teachable Machine that actually did the hard work of building the model. One of the 3 party tricks it knows how to do is to build an AI model that can classify images. So I just wrote a simple Python program to collect training data. And then after the first round, I updated that model to pre-classify the images. So it was not only collecting data, it was pre-classifying it. So I didn't have to classify everything from scratch. All I had to look for was errors. And then there's a Python program that applies the model and creates the output that goes on the website. And really, this is the whole program from start to finish. But most of that program is just image manipulation and air checking. There's the actual call to the model itself is like 1 line. So the training process is, I mentioned that the first round was, created an initial model. And in version 1, we found that the all-sky image worked good most of the time, but dusk and dawn, when it was too dark to see clouds and too light to see stars, it would get confused, and it just wasn't very good in those periods. So we added a second camera, and then part of that program is it creates this square image composite, and they're squished a little bit, but they're always squished the same way. that shows a south-facing web camera and then the all-sky camera. And so as the system is collecting training data, it's also classifying it and then saving the file, including the classification of clear, partly cloudy, or cloudy. And that makes the next steps a lot easier because it's easy to sort out what training data represents what state. So if I look at my data file that's created by the training data, you can see the file name includes words like clear, partly cloudy, or cloudy. And so it's just a matter of selecting the ones that say clear and loading those into Google's Teachable Machine as the training data for the model. Now, you do need to go through and review it for errors. And so as you go through, you have a couple different options as you step through these. I step through them using Lightroom, but you could do it just browsing them with the image browser. Look at the data, find anything that isn't correct according to the way you think it should be judged. And then you can either rename the file so you can find it later. You could reclassify it by moving it to specific folders, or you could just delete the ones that are errors. Although I would argue that the errors probably should be reclassified and left in to improve the trading data. And then you upload this correctly classified training data to Google Teachable Machine, push the go button, and it creates the model that you can then download and use in a Python program. So any questions before we start into situational awareness cameras?
Yeah. One general question from Tarek is, what about security cameras? Do they have any value here?
Yes. Yeah, and that's kind of the next
For
section.
all, he's asking for all sky cameras.
I'm not sure I understand the question.
Can I adapt a security camera to taking a picture as an all sky camera?
Yes. Yeah, and in fact, that the Viculin and the Amcrest example that I showed are both sold as security cameras.
Okay.
For make sure that you're looking at one that is rated for outdoor usage.
Okay. And John at Astra asked, do the roofs close when the sensor sees bad seeing?
No. No, they will close based on wind. Clouds is the thing that usually closes them is clouds, because clouds will come before rain. Any moisture on the sensor will cause them to close immediately. And it doesn't take much.
And that's all configured in the software that's controlling the roof motor.
Yes. Yes. We have found that once it gets colder than about -5 Fahrenheit, mounts start having problems. So we also close the roof if it gets below -5.
Okay. Thank you. I think that's all the questions. There's a lot of discussion going on back and forth, but the actual questions are relatively rare.
Okay. So with that, let's talk about web cameras or situational awareness cameras. They're really handy when you're not sitting next to your scope. There are times you just want to know, where is it pointed, or to evaluate sky conditions. And then there's also a security aspect to it. The main thing you have to watch out for is you'll see a lot of cameras talk about their night vision capabilities, and those are either using either white light or sometimes infrared light in order to give you that nighttime performance. And you obviously don't want to use white light. You also don't want to use infrared light because that can fog your images. Most astronomy cameras are going to be sensitive to that infrared wavelength. And I did have the experience of having one accidentally left on in just an observatory with just my scope in it, and all the images were fogged that night from the infrared light. It's my fault, and I paid the price. So there's a couple different options. The simplest are like the Blink cameras that are a little battery operated Wi-Fi camera. They run off of a AA or 2 AA batteries. And the way they can run off of the battery is that they're not on all the time. They're just watching for motion, or if you connect to it and say, show me the current image, then it uses the battery. And they claim like 1 to 2 year life out of that battery. There are plug-in Wi-Fi cameras, and probably the Wise cameras line is the most common I see. Those are also Wi-Fi, but rather than depending on a battery, they have a USB adapter, and they're run off of a USB power adapter. They also make battery and or solar powered Wi-Fi cameras, and we do have one of those that works well. You can have a USB connection camera where you're actually running the camera off of a simple USB connection off of your computer. The most flexible is an Ethernet wired camera, and we use Amcrest. And they're powered by this power over Ethernet. So you're running from a PoE injector or a PoE switch to the camera, and that's what powers the camera. And this is just an example of an image from one of those cameras. You can see the Milky Way up here. You can see the stars. And this is with no moonlight. So simple, kind of seems approachable for most of us would be a small astronomy camera, like the ASI 120 MC, and it even comes with this little screw-on fisheye lens. So real easy to set up. You can just plug that into your imaging computer. You can use something as simple as the ASI Studio that ZWO provides, or you can use a tool like All Sky Eye, which is a much more involved program designed for kind of do-it-yourself all sky cameras. It has a lot of functionality, probably more functionality than you're going to need. But then your image is viewable on your imaging computer. But unless you have other networks and other protocols in place, that's about the only place you're going to be able to see that image. So easy to set up, but somewhat limited in how you use the image that comes from it. The Blink battery powered, again, it's powered by a AA battery. It does require a Wi-Fi connection. It'll either capture motion or on demand. The way they're configured is you view them using an app on a phone or a tablet. As far as I know, there's not a way to view them on a computer. So you're limited to viewing them on a remote, some sort of a portable device. But they do work reasonably well and are fairly inexpensive. Wise cameras are similar. The only difference is it's a USB power adapter rather than a battery, but it requires a Wi-Fi connection. Because it has its own power, it can capture continuously. It can send you alerts to motion if it detects motion. It can even alert you as to what kind of motion. Was it a person, a car, a pet, a package being delivered? But again, it's viewable only on portable devices, not on your computer. And you don't have to have a subscription to use it, but from our experience, it works best if you do have a subscription. And if you watch if you're going to go this direction, if you watch the Prime days, that can be a good time to get your subscription. The Amcrest or other brand PoE cameras give you the most power, robust flexibility. They're powered by power over Ethernet, so you do have to run a wire to each camera, but it's just the one Ethernet cable. It can capture continuously. It can be viewable on either a portable device or on a computer. You can have tools with Blue Iris to upload snapshots to a website, which is one of the features we use quite a bit. But you need some sort of a PC app like Blue Iris if you want to capture images and propagate them out to other platforms. So here's some sample images, and this is just to show you the scene that we're going to be looking at. So it's this telescope on a portable pier. In this case, this observatory was closed when I took this, but that's just to show you what we're going to be looking at. This is an example using the ASI 120 MC. It's a very wide field of view. You can kind of make out the telescope here and some stars in the distance. I think this wound up being a 10-second exposure. I experimented with different exposure times, and longer exposures didn't seem to help a lot. Because it's such a wide field of view, it also picked up this wall that's right behind the telescope, as well as even the part of the Amcrest camera that was off to the side. But it does work. And this was just captured with ASI Studio. It allows you to see the scope, see the mount, see where it's pointed, see the sky. So, from that perspective, it does work. And this was captured at a time when there was no moonlight. This is from the WISE camera sitting right next to it at the same time. And you can see without moonlight, you can see a few stars here and there, but you really can't see the scope. If you turn the brightness up on your screen on your phone or tablet all the way, you can make out a little bit more detail, but there's just not much there. Now, when you do have moonlight, you can see quite well with the WISE cameras. So it does work. It just doesn't work as well. And you do need to be careful with these, as with any of them, because they frequently will have infrared lights that will turn on automatically when it gets dark. So you want to make sure, no matter what you're using, that you have that disabled. This is the Amcrest PoE camera. And again, this is without any moonlight. Just, this particular camera sitting on the floor looking up. You can see stars, you can see a little bit of the Milky Way, you can see details on the telescope. This, to me, by far gives me the best image. Now, to do this, you have to use a fairly long exposure time. So, as you know, with long exposure times, motion is going to be blurred. So if you're counting on this as a security camera to identify an intruder, that's probably not going to work unless they hold real still for you, because it is using, I think, a third of a second exposure. So any motion will be blurred.
Craig,
Yeah.
what is the purpose of the range of cameras you're showing us? Is it just to find out where your telescope is pointed and it's safe to close the roof, for instance, or is it to protect from intruders, or is it both of those? Is it all of those?
It's
Cameras are better than others at that? What?
Yeah, it's really all of that. The main focus for me is to be able to visualize the equipment and see where the telescope is pointed. Um, I would use the camera in a different way for instance, we have one pointed right at the entrance to the observatory, and that does have an infrared light enabled, but it's completely shielded from the observatory. But that lets you see any motion or intruders or anything that's happening. So you would probably use a combination of possibly different kinds of cameras. We have at least 3 or 4 different networks of cameras at the observatory, some focused on security, some focused on situational awareness.
Okay.
So I'm focusing more here on just the situational awareness.
Thank you.
So one of the things I like about Amcrest cameras is they're still quite inexpensive. A year and a half ago, these were $49, and they're now over $60. So they have gotten quite a bit more expensive, but still pretty reasonable. These are basically the same camera in 2 different form factors. One is this bullet shape that's good for mounting on a wall or a post. And then this turret shape, we usually use those upside down, sitting on top of the server cabinet at the telescope position looking up. And as I mentioned, if you have a PoE router or switch, you can just plug these straight into the switch and it gets power and you're good to go. If you don't have a PoE switch, then you can get an inexpensive PoE injector. So this just plugs into an AC outlet. The Ethernet goes in and comes back out with the power added. So in terms of the network, you might have one set of cables going to your computer. You might have another going through a PoE injector, and then from that to your camera to monitor your equipment or to work as a security camera. If you have PoE switch and other devices. You might have a network that looks more like this with the PoE route switch, the remote power switch, cameras, weather system, computer, and then your network attached storage for a shared drive. Or you could use a PoE injector. I mentioned the Amcrest also has a mobile app. So not only can you look at it through Blue Iris, you can connect each camera to the mobile app, and it works outside the local area network. So, if I'm driving down the road somewhere and have Wi-Fi or internet access on my phone, I can pull up this app and look at the scopes and tell where they're pointed. So connecting to the Amcrest app, basically this is the sequence you would follow. Install and connect the camera to a network with PoE. Open the Amcrest app, go to Device Manager and add device, and then select PoE camera, and then select the P2P connection. And once you've selected that, then you can use your phone or tablet to scan the little QR code that's on the camera itself. Give it a name, user ID, and a password, select Start Live View, and you're online. So it's pretty straightforward to add new cameras to the Amcrest app. And once you do that, then you can use the Amcrest app to view the camera from anywhere.
Are the cameras generally auto exposure?
Yes.
Thank
Yeah,
you.
in fact, I'm going to talk, that's one of the things you do have to spend some time configuring if you want them to work well at night. And it took me a little bit of time to find all those settings. To configure the settings, first you have to do this from a computer. So you have to find the camera's IP address, which is not obvious in that little app that's on your phone. But they do provide an IP config tool that you can download from the Amcrest website. So you would download this IP config tool, run that to find any Amcrest cameras and their associated IP addresses. And then in a browser on the local area network, you would enter that IP address, and then it'll bring up this little login screen. So basically each camera has its own little web server built in. So you're actually connecting over the local area network to the web server built into the camera. Once you're connected to the camera, then you can select setup, and then go to the camera and configuration. First thing you might change is or at least consider, is profile management, whether you want it to be general, full-time. So you might want it to use a full-time daytime configuration or full-time nighttime. I have mine configured for day-night. So when it's nighttime, it will switch to a different set of settings than it uses during the day. So that's the first thing that I would do, is change the profile to day-night and then click Save. Then I would go to under configuration, you have picture exposure, VLC mode, and so forth. And of these, exposure is probably the most important. And I have found not all cameras have the same firmware capabilities. So the ones I'm showing, I do know have this. So you can select which profile you're setting your exposure settings for. So in this case, it would be, these are the nighttime settings. I have anti-flicker set for outdoors. Mode is manual. Shutter is customized range. And then that opens up these two rows where you can give a range of shutter speeds from 0 to 333 milliseconds, or a third of a second, and gain from 0 to 80. And I found these settings work quite well in a nighttime situation with no moonlight. And it took me some experimenting to find that. So this is the exposure mode. And then I also typically go to the picture mode, and I've made a couple changes here. You can see the brightness I've increased just a little bit, but I've increased the gamma, which is a Yeah, if you're thinking of stretching, what you're doing is applying a gamma curve. So this gamma is stretching the image, and I found somewhere around 77 works well. If you need to mirror the image, you can. If you need to flip it, for instance, you've got the camera upside down, you need to turn the image right side up, you can do that here as well. So those are the main settings that you need to do within the camera. And then on the computer, I mentioned I use Blue Iris software. It's unfortunately Windows only, I believe, but it can view, record, manage. It can upload snapshots to a website. It's only $80 for the full version, which supports up to 64 cameras, or $40 for just a single camera. And this is just an example of what that screen looks like when you're looking at a bunch of cameras in kind of full screen mode. But you can go through and configure individual cameras, or if you have one configured, you can very easily copy those settings to other cameras. So it makes, once you've got the first one configured, it makes adding new cameras very easy. One last thing that we use the cameras for, our buildings all have locks on them so that the roof can't move in the case of high winds. They don't normally move, but just in case, we've got a 1-inch steel bar that gets pushed through this lock plate or strike plate on the building. This is all attached to the concrete foundation, and then there's a linear actuator that pushes the steel rod into the strike plate. So we can lock the buildings based on the weather. The locks will automatically unlock if the roofs are going to open. The interactive astronomy software that controls the roof has the option to have it run an external application before opening or closing. So it runs a series of steps that, among other things, will unlock the buildings if they're still locked. One of the observatories, it even rings an alarm because that roof opens over the porch where you would enter the observatory. But by having a little video camera, and these are just little Wise cameras, at each one of these locks, our best practice is that we'll manually unlock the building before it's time to open, and then we'll visually confirm that it's locked or unlocked by using the camera. So that's kind of systems and networks in a nutshell. Any questions?
Greg, could I ask if I'm here and my computer is all set up and as you described it in my observatory, which is out in the desert, how do I talk to my computer?
I use Google Remote Desktop.
It's just a remote desktop application that we've all used.
Desktop application, yeah, that would be, I use Google. Some people use AnyDesk or TeamViewer. There's a variety of different remote desktop tools you can use.
I would imagine most of us have used those and know what they are, but could you please give us a brief explanation of what they do and what capability they have?
Yeah, it basically lets you operate a computer that's somewhere else as if you were sitting at it. So the remote desktop basically turns your keyboard, mouse, and monitor into the keyboard, mouse, and monitor of that remote computer. So in my case, all of my imaging software is on the remote computer. When I access it with remote desktop, then I use my keyboard here at home as the keyboard on the remote computer to set up the software for the night.
Thank you. If you're finished with your presentation, you can stop sharing and then we'll see you as you
Okay.
I think some of the other team here at the Astro Imaging channel have been reading through the comments, and I think we've got all the questions and comments covered, haven't we?
Yeah, I
think
think
so.
we're pretty good. Craig, I use the Wise camera for a different purpose with our solar scope that we operate remotely. And I use the tiltable version, which when you want to look around,
Yep.
it's really interesting. And you can view it on a web browser if you use WiseBridge.
Okay. I have not seen that. That's new. They're new for me anyway. Is that a new tool?
I think it's in GitHub. I can't remember where I found it. But the tiltable version of the camera, because generally you have a camera that's pointed in one direction. You said, gee, if I could just look over here a little bit.
Yeah.
So they're kind of cool.
Yeah, we have some of those. And do you use that with your solar finder?
Yes, because otherwise with a 5-meter scope, you don't know how far away the sun is.
Yep.
You could be a little ways and be lost.
Yep. That's a good application.
Craig, we do have a question from Marcia, who asked the earlier question about the Mac and Windows compatibility. There are remote desktops used on a Mac that can go ahead and control the Windows PC remotely. Are there?
Yes.
Yeah,
It's-
okay.
Yeah.
We just have to find the right one for you. Linda, were you responding to Marcia in
Yeah.
your?
Yeah, I was.
Okay.
Yeah. Google Remote Desktop. I believe you can use Mac or Windows.
Yeah.
It doesn't really matter which one you're using and which one you're connecting to.
Yeah,
No,
pretty
as long
much
as you-
all of them don't really care.
Yeah.
I use Chrome Remote Desktop to connect to my computers from my phone. It's great.
Yeah.
You can use any desk and no machine and stuff too.
I wouldn't want to downplay any one, but Chrome Remote Desktop is pretty robust and pretty dependable.
Yeah.
Yeah, I've only found two drawbacks with the Google Remote Desktop. The biggest one probably is that it's tied to a Google account, a Gmail account. So what I think most people wind up doing is they set up just a dummy Gmail account that's dedicated to that use, and then that's what they use as their Google account that's connected to both on the remote computer and your home computer. Fortunately, your Google account that you're using for remote desktop does not have to be the same Google account that you're using for Gmail on that same computer. It keeps track of them separately.
Yeah. Well, do you want to be part of our club or don't you?
Yeah.
Craig, if I've got a bunch of images that I took last night, and Nevada Desert Skies wants to know, he's got a bunch of stuff that he did out on his remote observatory. He wants those data files into his home computer. How's the best way to get them there?
I use Dropbox. So with a shared folder between the remote computer and my home computer. So as the images are captured, then they automatically also show up on my home computer.
If you wanted to, those very same remote desktops usually have a transfer file system on it too. And
They do.
And
you could also use something like WeTransfer, which is a free tool to transfer large files.
Yeah, there are two synchronization apps that might be useful too. One's an open source program called SyncThing, which works well, especially if it's just one or two people. But if you need to manage a team, then there's another application called Resilio Sync, which has a free and a paid version, but the free version is fine for anything we do.
how do you spell that, Linda?
RESILIO Sync, SYNK. And the other one is SyncThing, one word, SYNC thing.
Thank you.
If you don't want to do a Dropbox subscription and you have lots of disk space at home.
Okay, I think we've got the questions.
Alrighty. Well, that's all the questions. Thanks so much, Craig, for coming on. Always appreciate having you here. And this is a great topic that has a lot of confusion for a lot of people. So hopefully people have a few more answers and some directions to go look in for making their home observatories and remote observatories work better for them.
Thank you for having me.
Yeah. So week after next, the 19th, we have John Talbot with discoveries of nebula around cataclysmic variable stars. That should be a fun scientific sounding talk. Yay. Let's see. was I going to say? Yeah, if you want to come give a talk on here, I recommended the 3D printing topic at the top of the show. If anybody in particular wants to give that talk, please reach out on the astroimagingchannel.org on our contact us page. If you have any other topics you'd like to talk about, please also reach out. And don't worry if it's a topic that we've covered before in the past, because this hobby is changing so fast and things need updating all the time. And in fact, you could even go back through the old talks and say, hey, that talk from like 2020, that app is totally different now. We should talk about the updates, stuff like that, or totally different processes in PixInsight, all kinds of stuff. So yeah, please reach out to us if you are interested in giving a talk. And we're also looking for one more streamer to come join us as well. So we will teach you how to run the stream and give you software for it. And so if you're interested in joining our team and being one of our streamers, then we'd love to have you on. So please also hit up the contact us page. You should have a good internet connection and a decent computer for doing this, so we have a nice smooth stream.
And before you end, Craig, you can stay on with us if you want. John, I don't see your picture, but if you're still there, why don't you stay on? Why don't you stay on for a few minutes once we end it?
Yep. Yeah, if you're part of the team, then you get to stay on for the pre-show and after-show chat and talk to our speakers and talk amongst ourselves, and it's a fun time. Okay, I think that is all. So I will bid you good night. Take us out, Jaime. Good night, all.